to solve it by using
हेलो
simplex method? Yes.
मैम, वो थर्ड सम ओपन करने का था ना, डाउट था थोड़ा।
कौन सा
सेकेंड मेथड
और
का
भी
थर्ड
डाउट
सम।
है?
हाँ, मैं
ओके
बोला
ओके
बट वो फिर वो ऋतिक पूछ रहा था, सो मैं पूछ रहा।
ओके 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 वेट वेट, उसमें भी कुछ मिस्टेक है क्या?
नॉट
हाँ,
श्योर।
ओके टेल मी।
इसमें जो
डू यू
सेकेंड
वांट
टेबल जो
इन
थर्ड
इन
सेकेंड,
सेकेंड टेबल? हाँ
इसमें सेकेंड सेकेंड, हाँ, तो
हाँ,
इसमें
दिस
रो
वन।
ट्रांसफॉर्मेशन।
एक मिनट, आई थिंक दिस इज फर्स्ट, हाँ दिस इज सेकेंड, हाँ
मैम
टेल
इसमें
मी।
रो ट्रांसफॉर्मेशन लगाया तो फिर इसमें जो एक्स बी का जो कॉलम है उधर फिर 3
हाँ,
आना चाहिए ना, एक्स टू इज इक्वल टू।
wait. What are we doing? R2 is equal to R2 by 5. Yes. Oh my God. Why this mistake has happened? Yeah. You are right, Sagar.
उससे फिर A1 भी चेंज होएगा मैम, 8 होएगा A1।
Let me check. Let me check. What is R1? R1 is equal to R1 minus 4R2. So 20 minus 12 will be 8. Yes. You are right. Anything else? Other
नो।
these calculations are correct?
यस मैम,
These
पर इसमें
calculations are okay? हाँ हाँ
मैम इसमें वो समझा नहीं, वो माइनस जेड जे माइनस सी जे है उसमें,
हाँ।
वो वाला टेबल S2 वाला कॉलम क्यों सिलेक्ट किया एंट्री के लिए? X1 वाला होना चाहिए था ना, अगर -11 है।
यस, एक मिनट, मुझे चेक करने दो, ऐसे कैसे हुआ? तो पूरा कैलकुलेशन ही बदल जाएगा ना?
हाँ, अगर X1 सिलेक्ट किया तो
हाँ, इट शुड बी दिस, यू आर राइट, इट शुड बी दिस, इट शुड नॉट बी दिस।
फिर X के X2
यस 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 यस, इट शुडंट बी दिस। वेट, आई विल डू। So have you done, Sagar, this? Can you tell me the entries so that I will correct it?
मैम मैंने सिर्फ सेकंड टेबल तक ही किया, फिर मैं भी कंफ्यूज हो गया कि मेरा रॉन्ग है कि प्रिंटिंग मिस्टेक है, सो फिर मैं रुक गया उधर।
तो अपने आप पे
सेकंड
भरोसा
टेबल
रखो
तक।
ना। ओके
हाँ, सेकंड टेबल तक किया।
okay, okay, fine. But good that you are doing it. Anybody else has solved it so that I can rectify it now only? Otherwise, it will take time for me to do the calculation.
Ma'am,
Yeah,
if we
this
find any
shouldn't.
mistake, we'll inform you.
Yeah, sure. It will be better. Because sometimes in a hurry, you know how much tables I have to prepare and all those things are there. So sometimes in hurry, it happens. But it should not happen. Anyway, so what type of calculation will change? Which will be the leading element? This will be the leading element, right? 11 by 5 will be the, no.
नो,
No, wait. First, let me find the ratio. What will be the ratio? 5 into 8. So ratio will be, oh my God, 40 divided by 11, right? And this ratio will be 15. Sorry. So this is minimum, right? 40 by 11 is minimum. And so this will leave the basis. And in place of it, who is coming? X1 is coming. So here it will not be S2. Here it will be X1. So let's finish this example only today. So try to help me now. Can you do it now? We have to make this 11 by 5 as 1 because it is a leading element, right? So to make this 11 by 5 as 1, what do we require to do? R1 will change to R1 will change to R1 into 5 by 11, right?
Yes, ma'am.
And this we have to make it as 0, but now here it will be 1. So we have to multiply by 1 by 5 to R1, and then we need to subtract it from R2. Then you will get 0 over there. Now help me in the calculation. Okay. X1 is, I will find out the value. So variables are now X1 and X2, because in place of A1, who is coming, who is entering, X1 is entering. So variable names are right, X1 and X2. What will be in the column of CB? X1 is, coefficient of it is in objective function is -4, right? -4. And x2 ka coefficient is -3. Fine. Now all these entries will change. So let me remove it from here. Okay. Now tell me the entries. What we are doing, multiplying by 5 by 11 to first row. So this will be 5 by 11. So 40 by 11. Right? Then this will be 1. Then 0. Then -5 by 11. And then 5 by 11, 5 will get cancelled, 4 by 11. Am I right? Are you with me? Am I audible? Am I
Yes,
audible?
ma'am. Yes.
Yeah.
Yes,
So
ma'am.
just check whatever I'm writing, it is right. Why I'm not writing the column of A1 now? Because A1 has left the basis, right? And I told you in the note that if artificial variable is leaving the basis, you can omit the column corresponding to artificial variable in the next table, right? Okay. Now look at this second row. What I need to do is R2 is equal to R2 minus R1 by 5. So 40 by 11 divided by 5, how much it will be? 8 by 11, right? And R2 is 3. 3 minus 8 by 11. Can anybody tell me? 3 minus 8 by 11. So it is 25 by 11. Just check out the calculations,
Yes.
sir. Yeah. Now here what it will be? R2 minus R1 by 5. So what is R2? 1 by 5 uh, into this 1 by 5. So this will be 0. Next, a column of x2. 1 minus 1 by 5 into 0. So it will be 1. Next, R2. What is R2 in column of S1? 0. 0 minus 1 by 5 into, so 5. So it will be plus 1 by 11. And what will be here? S2 column minus 1 by 5. R2 is there. And minus 1 by 5 into 4 by 5. So it will be minus 4 by 25. So I have to multiply by this. So minus 5 plus 4 is minus 5. Let me write somewhere. I also need to do the calculation. So what will be that entry? Are you doing with me? Minus 1 by 5 minus 1 by 5 into 4 by 5. So it will be minus 1 by 5, minus 4 by 25. So minus 9 by 25. Just check it out. It will be minus 9 by 25, right? And now what will happen here? ZJ, CBY, XJ. So minus 4, minus 3. Sorry, minus 4 it is. Next, this will be minus 3. Next, minus minus plus. Plus how much? 20 by 11 minus 3 by 11. So minus, sorry, 17 by 11. Next, minus 16 by 11 plus 27 by 25. Can anybody do this calculation and tell me? So this will come out as minus 4 plus 4 as 0. Then this will come as minus 3 plus 3 will be 0. Then this will be 17 by 11. Are you doing this? How much is coming? Minus 16 by 11 plus 27 by 25. I hope it will come positive. Is there anybody who is doing this, or I have to do it? Let me do if you don't want to do. I hope you are getting the calculations. Minus 16 by 11 plus 27 by 25. So minus 16.
Minus.
Is it coming out minus?
Yes, ma'am.
Minus
0.37.
How much?
Something like that.
How much?
Minus 0.37. I'm getting that.
Okay. Minus 0.37. But then one more table will come, right? So Z, how much will be ZJ minus CJ? It will be minus 0.37. Now one of them is again negative. So this will enter into the basis. And then again you have to find who is leaving the basis, right?
Yes, ma'am.
So yeah. So I will make a correction. I will prepare one more table and will post over here. Okay. So I think this remaining things, they are not right. But it's good that you are solving it and telling me. I don't know why it has happened. I will definitely check it out if any other mistake is there. But you also please check it out. Is there any mistake in calculation? Okay. Okay.
Yes, ma'am.
Yeah, I will do the correction and repost it in the Google Classroom. I will remove the earlier one and put the new one again. Okay. Fine. Now, I think I have not explained the Big M method theoretically. I told you how to solve it, but let me explain it theoretically also. Yeah. So, what is Big M method? Okay. Before that, first, what is artificial variable? Can anybody tell me what is artificial variable? Where are we taking it? Why are we taking it? Can anybody unmute and tell me?
फिजिबल बेसिक सॉल्युशन बनण्यासाठी आपण जे घेतो ते जसं 1001
When are we taking? When are we taking? In which type of constraints are there? Because of what?
ग्रेटर
value?
दॅन इक्वल
Yes, exactly. When the constraints are of greater than or equal to type, we are subtracting the surplus variables to make those constraints of equal to type. And then we are not getting identity matrix. Why do we require identity matrix in matrix A as submatrix? To get the initial basic feasible solution easily. But that we are not getting when we are subtracting the surplus variable. So we are adding another type of variable which is called as a artificial variable. Okay, but remember that the cost of the slack and surplus variable is 0 in the objective function, whereas the cost of the artificial variable is mentioned as minus m in the objective function. Remember that point. So till now, which different kind of variables we have seen in LPP? We have seen slack variables, surplus variables, and artificial variables, right? What will be their coefficients in the objective function? The coefficient of slack and surplus variables will be 0, 0 in objective function, whereas coefficient of artificial variable in the objective function is minus m. Okay, now look at here the steps of big M method. What are they? The steps are like this. Express the LPP in standard form by introducing slack or surplus variable, if any. That means expressing it in standard form means which things we are doing. We have to look for the objective function. If it is of minimization type, we have to convert it into maximization type. We have to look for the BIs. If they are negative, then make them as positive by multiplying that corresponding constraint by -1 on both the sides. If the constraints they are of less than or equal to type or greater than or equal to type, add the slack variables or subtract the surplus variables and make them of equal to type. And what is remaining? If the variables are not non-negative, that means if they are unrestricted in sign, then replace those variables by, say, if x1 is unrestricted in sign, then replace x1 by x1 dash minus x1 double dash. Okay, I have not taken any example of that kind while solving by simplex method or big M method when the variables are unrestricted in sign. But I have taken in standard form. What we are doing when variables are unrestricted in sign, we are replacing those variables by, say, x1 dash minus x1 double dash. Now, same thing you will do it over here also. So if you are replacing the variables by dash minus double dash, now instead of one column, you will get two columns. For example, if x1 is unrestricted in sign, you will replace x1 by x1 dash minus x1 double dash, where x1 dash and x1 double dash, they are greater than or equal to 0. Now, in place of x1, you have two other variables, x1 dash and x1 double dash. So, in simplex table, you will get two columns, one corresponding to x1 dash and another corresponding to x1 double dash. But remaining procedure is same. There is no any change. Okay, same case in big M method also. Okay, so first step is convert the given LPP in standard form. Now, what second step tells you? Introduce non-negative variables to the LHS of all constraints of greater than or equal to type constraints. So I told you, when surplus variable we are subtracting, I'm getting the coefficient of surplus variable as -1, and hence I'm not getting initial basic feasible solution easily. So we are adding one extra variable which is called as artificial variable. Remember, even though the constraint is of equal to type also, even though the constraint is of equal to type also, still we are adding artificial variable in that constraint because I want to get the initial basic feasible solution easily. That means I want to get the identity matrix as a submatrix of matrix A. Okay. So when you are adding artificial variable, the constraints are of greater than or equal to type, or even they of equal to type also. Okay. These constraints are called as artificial variables. Sorry, these variables are called as artificial variables. The purpose of introducing artificial variable is just to obtain an initial BFS. That's it. Okay. However, Addition of these artificial variables causes violation of the corresponding constraints. Therefore, we would like to get rid of these variables and would not allow them to appear in the optimum simplex table. Right? I don't want them in as a solution of my LPP. So what should I do for this? So we are assigning a very large penalty minus m to the artificial variables in the objective function. Even after this, some of the variables, they are remaining in the optimum solution, right? That is noted afterwards. See, after doing this, you solve the LPP by simplex method. At any iteration, of the usual simplex method, there can arise any of the following three cases. It should be like this. Here it should not be full stop. Which cases you go on solving the LPP by BGAM method. Actually, it is simplex method only. Just we are adding the artificial variables also. So till what you are going to do the iterations, you may come across one of the three cases. Now, what is the case one? There is no vector corresponding to some artificial variable in the basis. In such case, proceed to step 4. Like what we have seen here. See, you can see in the third case, even though it is wrong, I will do the correction. But suppose this is your optimum table. That means all the zj minus cj are greater than or equal to 0. Okay. Then is there an artificial variable remaining in the basis? No. So this is what is the first case. What the first case tells you, ki there is no artificial variable remaining in the basis in the optimum table. Okay. Then go to step 4 means application of simplex method until either an optimum solution is obtained or there is an indication of existence of unbounded solution. So in this case, actually, you are getting the optimum solution. Okay. But what is the second case? There is at least one vector corresponding to some artificial variable in the basis at level 0. That is, corresponding entry in the XB is 0. Also, the coefficient of m in each net evaluation Zj minus Cj is non-negative. In such case, the current BFS is a degenerate one. This is a case when optimum solution to the given LPP includes an artificial variable and an optimum BFS still does exist. Means what? Means, suppose you are getting all Zj minus Cj greater than or equal to 0. Right? That means our condition is satisfied. But if you look at the column of XB, there is say one artificial variable, more than one also possible. But value of the artificial variable is 0. At 0 level means what? Value of the artificial variable is 0. Suppose A1 is the artificial variable which is appearing in the final simplex table, optimum simplex table, and its value is 0. Then what we are saying? Yes, optimum solution to the given LPP exists, but it includes artificial variable also. And because it includes artificial variable, we are calling the optimum solution is optimum BFS is degenerate. Why it is degenerate? For example, I will tell you. Suppose, see, how many original variables are there in this LPP? Original variables are 2, right? And if you look at here also, initial BFS, only 2 variables are there in the initial BFS. Fine. So finally, from the suppose in this table, you are getting all Zj minus Cj greater than or equal to 0. And also here, suppose you are getting A1, suppose in the final, this is your suppose final table. And here you are getting A1 is equal to 0. And all the entries are positive. Suppose I am telling you, suppose all Zj minus Cj you can see here are greater than or equal to 0, right? So current solution is optimum solution. But in the column of XB, still artificial variable is there, but its label is 0, means it is taking value 0. So can I say that optimum solution exists to the given LPP? Yes, it exists. Why I can say? Because even though artificial variable is here, if I put its value in the objective function, minus m into 0 will be 0. So has it affecting my objective function value? No. So I am saying that optimum solution is existing. But how the optimum solution is, now you can say value of A1 is 0, X2 has positive value. But what about X1? X1 is not appearing in the basic solution. So its value is also 0, right? Now X1 is 0 and X2 is positive. And you know that when one of the variable is 0, then we are calling it as degenerate basic feasible solution. Because X1 is 0, we are calling the solution as degenerate basic feasible solution. Anyway, so what I want to tell you, if artificial variable is there in the basis but its value is 0, I am saying that our optimum solution exists. But suppose if its value is say 1, for example, if artificial variable is there in the basis in the final table, but its value is positive, then what am I saying? We have seen one example. What I am saying? The value of the artificial variable is positive in the final table, then what are we saying? Whether optimum solution is existing? Yes or no? Am I audible? Am I audible? What are you people are doing?
Yes, ma'am.
Yeah. So can anybody tell me if artificial variable is taking some positive value in the XB column and the all Zj minus Cj greater than or equal to 0, what shall I call it as? Whether
So,
optimum
pseudo solution.
pseudo solution. Right. Right. And that is what, let me change the entries over here. Yeah. So what will be the third case in the BigM method? Third case is at least one artificial variable in the basis, but not at level 0. That is, the corresponding entry in the XB is non-zero, and also coefficient of M in each net evaluation is non-negative. In this case, the given LPP does not possess an optimum BFS because M, in such case, we say that the given problem because of M, right, involved in the objective function. In such case, we say that the given problem has a pseudo optimum BFS. We have seen one example for it. Okay, so application of simplex method is continued until either an optimum BFS is obtained or there is an indication of the existence of unbounded solution to the given LPP. Okay. And what is the note? Note is while applying simplex method, whenever a vector corresponding to some artificial variable leaves the basis, we can drop that vector and omit all the entries corresponding to that vector from the next simplex table. This is what I told you. Suppose A1 is leaving from the basis, the entries corresponding to A1 in the next table can be omitted, the column corresponding to A1, Remember, even if you don't omit it, that is fine. Okay. But if you omit it, your calculation will get reduced. Okay. So in the this one Google Classroom, I will change that problem sheet. Hope all of you understood the method. Is there any problem? You got the method? Any doubt is there? So want to say, Sagar, no doubt, or you didn't get the method? Sagar, no doubt. Fine. Anybody else has any doubt? Okay. Now the only last concept related to LPP is remaining, and that is called as duality. But I don't want to start it now because only 5 minutes are remaining. So what I will do is in the next